Okay, now we have another example to find all zeros of a polynomial. So I gave you x to the fourth minus 5x squared plus 6x minus 2. So this 4 right here tells us that we are going to have 4 zeros. Okay, so first step, we want to list out what are all of our potential zeros, and then we're going to do synthetic division from there. So we are in standard form. Mind your Q's and P's. If nothing's written, it's an understood 1. Everything that multiplies together to give us 2 is just 1 times 2, and everything that multiplies together to give us 1 is just 1. So we actually have 4 potential options, right? We have positive 1, positive 2, and we have negative 1, negative 2. And we didn't give you any hints on this one, so potentially you'd have to do synthetic division 4 times, which isn't terrible. So let's start with negative 1, right? Let's just start with the first option, see what it gives us. So make sure you've got those placeholders. So it's 1x to the fourth, 0x cubed, negative 5x squared, 6, negative 2. All right, fingers crossed. Let's see if we get lucky. 1, negative 1, negative 1, 1, multiply, add, multiply. Oh, nope. Okay, so negative 1 is not an option. All right, let's try negative 2. Okay, 1, 0, negative 5, 6, negative 2. Bring down that first term, multiply, add, multiply, add, multiply, add, multiply. Nope, that's not going to work. Bonkers. So negative 2 is not an option. All right, let's go to those positive values. Let's try 1. Surely this one's got to work. So 1, 0, negative 5, 6, negative 2. Okay, bring down that first term, multiply, add, multiply, add, multiply, add, multiply. Woohoo! Yay! Perfect, perfect, perfect. So we know that x equals 1 is our very first zero. Okay, and we have 3 others to find. Well, we've already done synthetic division on negative 1, negative 2. The very last option that we haven't tried is 2. So bring down that first number, multiply, add, multiply, add, multiply, add. Oh, that remainder is not 0. So 2 is not an option. So if negative 1, if negative 2, and 2 are not an option, if the only one that worked was 1, then maybe let's try it again. What if it's a double root, right? What if it bounces off? What if, because none of these other options worked, and we're still at an x cubed polynomial, we need to get it down to an x squared polynomial so that we can factor. So let's try 1 again and see if we get a remainder of 0. Okay? So this is what we were left with, right? So now, instead of rewriting this, now I'm going to try 1 again. Let's see if it was a double root. Okay, so bring down that first term. 1 times 1 is 1. Add, multiply, add, multiply, add. Woohoo! Yes! It was a double root. So what does that mean? It means that at 1, something cool's happening, which you're going to see when we get to graphing. But 1 was a double root. And we were led there by default, just to reiterate, because -1 didn't work, -2 didn't work, and +2 didn't work. So the only option we had was to retry 1 again. Okay, and now we're down to an x² polynomial that we can try to factor, or maybe quadratic formula if we have to. This ends up with x² plus 2x minus 2. And unfortunately, we cannot factor that, so you would have to go to the quadratic formula. Formula is -b plus or minus square root b² minus 4ac all over 2a. So let's plug in our values. -2 plus or minus b², so 2 squared gives you 4, minus 4 times a, which is just 1, times c, which is -2, all over 2 times a, which is just 2 times 1. Okay, so then we end up with -2 plus or minus square root of 12 over 2. When we simplify our radicals, that becomes -2 plus or minus 2 root 3, right? Square root of 12, 4 times 3, take out those pairs, just if you forgot how to simplify those radicals. And then finally, you'll notice that all of these have a 2 in common, so we can divide those and end up with -1 plus or minus root 3. So there are 2 zeros, and there are our 2 zeros for a total of 4. And you did it!